Good morning. Welcome to the tutorial workshop number 2, entitled Advanced Big Data Analytics for Control Performance Assessment in Industry 4.0 Era. So we have a service website. It's called metronics.ucmc.edu/bigdata-CPA. So there are more updates on that webpage. My name is YangQuan Chen. I'm a full professor in metronics in UCMC. So today, in the next about 4 hours, we are going to discuss the topic centered around the big data analytics. So I want to thank the organizers to give us this opportunity to share with you our most recent thinking in this area. And this is very meaningful in the sense that this is our first IFAC MECC. It's supposed to be in Austin, Texas. So I want to thank my workshop chair, Professor Zhang, for organizing all these proposals, accept our proposal, and thank you for attending this presentation. So I want to share with you our organizers and presenters today. One is Professor Domansky from Warsaw University of Technology, and also Iro Viola is a senior PhD student in the MECC lab. MECC lab stands for Mechatronics Embedded Systems and Automation Lab. So here's a schedule. So I'm going to kickstart the Big Data Control Performance Assessment. Why now? Then Professor Domansky has recorded a presentation about the overview of this area, Big Data and the CPA. Then he's going to have another 1 hour presentation about traditional CPA, a review on the control performance assessment. After that, we're going to share with you our latest thinking about how to handle those outliers and anomalies in the data. What are those advanced data analytic tools? We're going to have a coffee break and discussion, and depending on the needs, we're going to have some more free chats. After that, I'm going to share with you some of our accumulated knowledge in fractional order signal processing with potential applications, advanced data, big data applications. Finally, we have Professor Domansky again present you with a case study in the process industry. So let's move on. So we want to ask the question, why today we talk about this? Who cares, okay? Well, what is the mega trend today for control people? So control people has some very interesting, proud that they are doing important things, which is true, I agree. However, we have to perhaps rethink about controls today in this new era, I call Industry 4.0 era. From this figure, you can see that, let me pull out my pointer. So you can see the control theory has so many different small directions and branches. So even people are more and more open to the idea of fractional order systems, where you have differentiation and integration of non-integer order. So I'm not going to elaborate too much on this map. But one thing is clear, without control, the world is going to be chaotic, even for yourself without control cannot even stand upright. Okay, to be able to stand upright, you have to be under control. So this is a traditional classic control system design philosophy known as MAD, modeling, analysis, and design. Without model, you cannot analyze. You have to try and error in a real system, but this is not possible today. So MAD is a framework for control people. Usually it's more on a model based. Of course, today people say the model can be data driven and data is the model. And that's a different story. I don't want to touch that side. But let's say a traditional one, control. Then traditionally, once you make the system work, you have to, when you design a system, you have to ask two questions about what do you want and what do you know, okay, basically. After the system is working, you tell the customer, hey, look, the system is working as we promised, but you have to show them it's working. So you need to have a way to tell the performance if the system is still working. At the same time, you have to address two questions about how robust and how optimal. So the robustness is also a part of the assessment. You can tell the system how robust it is. And you also can, based on the big data, you can tell how optimal. Is there an additional room for performance improvements and so on and so forth. So there are rich research opportunities, not only in the modeling and design and analysis, MAD side, but also on the assessment side. So CPA stands for Control Performance Assessment. This side has also a very big room for doing good research to answer the two questions, how robust and how optimal. Make that assessment and quantification. So that's my point. So right now, we need to talk about using the big data for this control performance assessment. The main reason is this two-word phrase. It's called digital transformation. This digital transformation is happening now and has been in our life for a while, from like a different section of our life, the whole life cycle. Not just technology, but also societal. People in the supply chain may feel this digital transformation better because they see the changes all the time and they see the performance improvements, which is real money. It's increased profit margin, okay? So the main features in this digital transformation era is the big data integration so that we can leverage AI, deep learning, and data analytics. Therefore, we can increase the operational performance. So I think nobody feels strange here. And we have been hearing digital transformation all the time. But what does that really mean? Because digital transformation can happen at different level, but not only just a process transform or technology system side, but also in the business model side. Okay, and you could have cross-domain transformation as well, even the organizational cultural transformation. So these are all the types of digital transformation. All this today becoming a popular term is because of the breaking technologies. We call it AI, deep learning, and data analytics. Okay. Of course, you have supported cloud computing, edge computing, all those things like that. So there's a Gartner's the Gartner's survey saying that 91% of the organizations engaged in some sort of initiative. Okay, so therefore, we need to embrace this digital transformation era. So as a control person, I think we need to go back to this picture and think about how the big data can enable us to better answer the question or quantify the robustness and optimality, okay? I know what else we can do, okay? What else we can do? So here is our 4.0, Industry 4.0 era. I think you have probably have seen that. Today we're here with all this breaking technology, like Internet of Things, cloud computing, multi-agent interaction systems, cyber physics systems, and so on and so forth. But previously, from like Industry 1.0, is steam power machines, production facilities, centralized. Then you have electrical power. Then you have computer automated manufacturing, the production line with robots, and so on, things like that. But today we have totally different setting, okay, different setting. So what we as a control people, what we can leverage in the Industry 4.0? What are the challenges in front of us? As I said, in the BigData-CPA point of view, we have lots of opportunities. So today we can say we can make our factory smart than ever before in the 4.0, Industry 4.0 era. So the renewed control engineering perspective is required. So today, basically, we were driven by this perspective, okay? So the megatrend towards the future, the nearest future, is, you can see here, we have 10 megatrend, okay? Like people-centric, locating independence and resilience delivery, okay? What we can give the resilience to the system. So they call intelligent composable business, AI engineering. So be careful, we no longer talk about AI, we talk about AI engineering. So think about chemistry versus chemical engineering. They are very different, okay? So I want to draw your attention to this one. It's called hyper-automation, okay? Hyper-automation. So the hyper-automation in the future, there are two things. The first, you should automate whatever you can automate, okay? So that's the first thing. The second thing is, for any of the real system, you should have its digital twin of that, even an organization, so that you can gain more insights from playing with the twins. Make sense? So all these are connected. So we are talking about why we need to talk about BigData-CPA now is because the Industry 4.0 era today, we have all these breaking technologies, okay? Like AI, big data, data analytics, deep learning, Internet of Things, and cyber physics systems, and so on and so forth. So we have much increased and updated knowledge of the system to be controlled. We have enhanced sensing and actuation capabilities. Say, for example, you have sensor-rich and actuator-rich situations. You have lots of sensors, lots of actuators, perhaps very high redundancy, okay? So today, in face of what we have just discussed, we need to ask the third question. In addition to how optimal, how robust, we need to ask the third question, how smart? Your control system, how smart, okay? How smart? So add this smart in here, okay? So that's our main driving force behind. So how smart with all this It's called edge computing. This Internet of Things, big data, machine learning, digital twins, cloud computing in a wave of digital transformation. So it's time to revisit and ask how smart, in addition to ask how robust and how optimal for a control system. So in general, the control people, they have very strong self-proud about what they do. On the other hand, we really need to embrace the change in the technology side here and start to give us more challenge. For example, asking how to make your control system smarter than before. How to do that? It's actually called a smart control engineering. We suggest. Okay, we suggest. So basically, these are control theory and control engineering. Again, I want to draw the chemistry versus the chemical engineering analogy. The control, you have two sides as well. Then we have all this new breaking technology and capacities today in the industrial 4.0 era. So together, we are going to say we need to, I think we should say something like this. We should do, this is the trend to talk about control engineering to be smart. It's a new frontier. We are going to give this tutorial to explain this idea in more detailed way with several case studies in our lab to demonstrate by asking how smart we can do lots of interesting things. Okay. But of course, how smart is smart? What signifies smartness? So we have 5 defining features here as specified by National Science Foundation Smart Autonomous Systems program. So the system tried to be cognizant, taskable, reflective, and ethical and knowledge-rich. So these 5 features will make your system smart. So let me go through one by one briefly. So the first one, cognizant, is linked to today's topic, or CPA, Control Performance Assessment. Because I can make that assessment, then I can quantify how smart, how optimal, and how smart, and how healthy the whole system is. So it's kind of self-aware of our capabilities and limitations, okay? So that we can face the dynamic changes and variabilities in the system. That's robustness, isn't it? Task meaning you can handle high level, vague human commands. So the system should have human interface, operator interface. And if the operator gives some irrational commands to the machine is smart enough to recognize the operator perhaps is mad. It's really mad. So they can refuse to take that command. Okay. So on the other hand, they are smart enough to be able to comprehend what you really want. Okay. So that's called taskable. So reflective, that means you accumulate the past actions and consequences, and then you can learn from the past so that you can improve in the future. That's exactly the AI machine learning part. Ethical is also important. So the system has to be smart to be ethical, okay? So like a robot, you don't want to hit a person. You want to hurt a human operator or hurt passenger and so on and so forth. That is a built-in feature. Then the system is a smart system, smart. Then knowledge-rich means the system can reason over a diverse body of knowledge from rich environment to the sensor-based information. So when you want to control, traditional way to think is you have a sensor, you have a actuator. In the future, it's not true. So sensor could have more. It's called sensor rich. You may have more than one actuator for redundancy. So it's called actuator rich. In this kind of richness, you gain more knowledge, okay, from diverse body of knowledge. And in the multi-agent case, you have like a group of robots. So you can even learn from your neighbors, from their success and failure, and so on and so forth. That's called knowledge rich. So together, we call building these features in control systems. So we call this is smart control engineering. So in the control, so as I said, the first thing first is to be cognizant, to be self-awareness of different things. So you can see the control performance assessment is a much needed, a core capability for enabling smart control engineering. So that CPA is a centerpiece to my point of view. You have to be self-aware so that you can improve, right? So if you don't know how well you are performing, so you cannot improve. So control performance assessment is the foundation to enable the self-optimizing. If you don't have self-awareness, how you can do self-optimizing, okay? And many other features, okay? Many other features within a smart control engineering, okay? So I want to draw your attention about this 2020 New Springer book by my collaborator, Professor Pavel Domansky, with very excellent exposure about control performance system with very balanced coverage on theoretical side and industry practice side with lots of case studies, okay? This is a big book, a few hundred pages, okay? Yeah, I have a hard copy somewhere. So I want to draw your attention about our books on outliers in control performance, control engineering, because we find out there are lots of outliers in our big data. For sure, you will have it. A traditional wisdom is to kill those outliers or remove them simply. That's not true. How do you know the outliers are not part of the dynamics, okay, or behavior? So then you cut it, then you only have a partial truth, right? How to quantify and leverage the knowledge about outliers in control engineering from a fractional calculus perspective. This is significantly, I feel very passionate about this topic, okay? I think it's the ever first, so it deserves your attention. This is being copy edited. It will show up in the market very soon. If you have an urgent need to take a first look, I can share with you information about this book with the overview chapter. So send me an email. So thank you for your attention. And we have Smart Control Engineering website is here. You can see for more information. And today's BigData-CPA tutorial workshop information I put in here. So with that, I'm open for a few questions. After that, we're going to move to the table of contents here. We're going to go through the recorded ones one by one.